This is proof number 23. All right, as we look at proof 23, some observations. We know we're dealing with angles because I see a diagram with some angles. Let's read this. Given that the measure of angle RSG equals 7x minus 2, the measure of angle RST equals 11x plus 3, the measure of angle GST equals 29 degrees. None of that's labeled in my diagram, but I know it's true because given statements, like witness statements, we're going to assume that they're true. We're trying to prove that x equals 6. This might remind me a lot of proof 22 because I see some algebra, I see some stuff I learned about in my last unit. I'm trying to prove something algebraically here. So let's go down to our thinking space and let's write down anything we are thinking about. It might be important, it might not be, and feel free to label the picture, the diagram if you want to. Just label it correctly. So the measure of angle GST is 29. It's not that whole angle. The measure of RSG is 7x minus 2. And then it's that whole angle RST. So this big measure, that's what is 11x plus 3. Okay, so again, going to our thinking space, let's write down anything we think we know about this. For me, your math teacher, again, I'm going to write unit 1.1 because that might help me kind of access where in my brain I stored information about this kind of thing. This looks like something we did last unit, and it is. It looks like I'm going to be doing something with angle addition. I know I have a postulate that goes with that, so I might, keep angle addition on my mind. I know I'm going to use algebra, and again, kind of like in that last proof, we're going to prove the value of x, so I might want to think about those properties. Sorry, my stylus isn't working very well. The properties of equality, those are on my mind. All right, you might write more things in your thinking space. You might write less. That's okay. Your thinking space is your thinking space. Okay, let's go ahead and take a look at this proof. Again, no matter what you're thinking about, even if you're drawing a complete blank, there's always something you can write, and it's that first statement. It's always given to us. So we're just going to copy down what it says after the word given. So the measure of angle RSG equals 7x minus 2. Oops, I don't like the way that looks. Sorry, this is the downside of trying to do this on an iPad. Okay, 7x minus 2. The measure of angle RST equals 11x plus 3. And then lastly, the measure of angle GST equals 29 degrees. We know that because it was given to us. Given is always our first reason. All right, we said we're going to do some angle addition here most likely. And as I look at this, like angle RST, I could add, I know I'm going back to my thinking space, angle RST, I can get that, sorry, I don't want to add that, but I can get that from combining RSG, so I might say, I'm going to scratch that, angle RSG plus GST. I should probably use the angle. Your thinking space can be kind of informal, so if you write RST and you don't write the angle symbol, that's okay, because it's your thinking. All right, that's actually going to take us to our next statement. So we could say that the measure of angle RSG, when we add to that the measure of angle GST, we're going to add those two smaller angles up to get the larger angle, the measure of angle RST. That right there is the angle addition postulate. All right. the next thing is that if you think about it, just like in the last one, 22 and 23 are real similar. We actually have expressions for all of these things, RST, RSG, GST. So we can substitute those values. So in line 3, instead of the measure of angle RSG, I can say 7x minus 2 plus, instead of the measure of angle GST, I could say 29. No need to include the degree symbol in the equation. And then instead of the measure of angle RST, I could write 11x plus 3. And I used the word a moment ago, but that's the substitution property. And you guys have learned about substitution in your algebra class before. Substitution means to replace one thing with something else that it is equal to, essentially. All right, from here, just like the last proof, it's just algebra. So think about this. Your step 4 could be different than mine. You might add 2 to both sides. You might subtract 7x. You might subtract 29. I'm not going to do any of those things. I'm going to do what I always do when I can, and I'm going to combine like terms. So if you look in step 3, I have a negative 2 and a positive 29. I'm going to combine those terms. So 7x, negative 2 plus positive 29 is positive 27, and that's equal to 11x plus 3. All right, so that is the only reason that we might use. That's not a rule, it's not a definition, it's not a postulate, it's not a theorem, it's just combining like terms. Okay, line 5, statement 5, and that's a 3. Don't let my whiteboard pen look confusing. Well, that just made it way worse. There we go. All right, statement 5. Again, lots of ways you could solve this algebraically. Your steps might differ from mine. I want to subtract 7x from both sides because I know if I do that, I'll have a positive coefficient for x. You might not like doing that. When we subtract 7x from both sides, we're going to have 27 on the left. 11 minus 7 is 4, so 4x on the right plus 3. I subtracted from both sides. That's my subtraction property. All right, I'm running out of room, so I had to move this up. I know you can't see the diagram, but hopefully you're looking at it right now in your study guide. All right, so we just used the subtraction property in step 5. In step 6, I think if you did what I did in step 5, it's natural to subtract 3 from both sides next. So in step 6, I'm going to subtract 3 from both sides. That gives me 24 on the left, and that's equal to 4x on the right. So I use the subtraction property again, and that's okay. We can use it as many times as we need it. Subtraction property of equality. All right, we're almost done. Hopefully if you get to this statement in some way or another, we'll divide both sides by 4. So we'll be left with 6 equals x. Because we divided, that's the division property. Because we divided on both sides, I should say. And now it just gets really picky. You know, honestly, if you did all this, I would probably accept this as your final answer. But if you look at your statement where you're asked to prove, it said prove that x equals 6, not that 6 equals x. So if you want to be like the most impressive, most incredible, most attending to precision mathematician in the world, I know that's a title we're all aspiring to. What you could do is you could actually rewrite this statement as x equals 6 and say that's because this is the symmetric property. Now you might have solved that equation a different way where x always remained on the left, and then you wouldn't have to do that. All right, that's it for this proof.